So I've got a couple questions here from the homework of the last couple days. It's 2-3's homework that I want to go over. The issue here with this question is the fact that we've got a lot of fractions here, right? Do you guys know what a least common denominator is? If we have, well, let's just say I've got the numbers 2, 5, and let's go 15. 2, 5, and 15. Don't even worry about the problem that's up there right now. 2, 5, and 15. Let's say that those are denominators for some fractions. And I'll just put them over 1. Okay? And I wanted to change those denominators, make them grow, but I want them to all grow to the same number through multiplication. Okay? So the idea here is what can I multiply 2 by, a whole number wise, so that it gets to 5, or that it grows to 5. And so we start thinking, okay, I'm going to multiply by 1, I get 2, multiply by 2, I get 4, multiply by 3 goes to 6, right? So there's nothing, so there has to be a number between 2 and 3 that I'm going to multiply to get to go to 5, right? And 2.5 would be that number. So through multiplication of whole numbers, we can't make 2 grow into 5. Does that make sense? I can make 5 grow into 15, though, right? Multiply 5 by 3, and I can keep 15, I can make it grow to 15 by multiplying by 1. It is 15, okay? So I can't make them all grow to 5. I can't make them all grow to 15. 2 times 7 will give me 14, right? 2 times 8 will give me 16, so I can't multiply them all to get to 15, okay? But do you guys see that if I multiply them all, that there is a value that I can multiply them all so they all grow to 30? Does that make sense? What do I multiply 2 by so it goes to 30? 15. What do I multiply 5 by so it goes to 30? 6. What do I multiply 15 by so it goes to 30? 2. Okay? That 30 that we're going to get them all to grow to is called the least common denominator. Okay? The LCD, if you've heard that before. Okay? And the way that we find it is ultimately we just take this number and we factor it. So 2 times 1 is essentially what that factors to. Okay, the prime factorization. We take 5 and we do the same thing. So these are prime numbers. But 15 as a prime factorization goes to 3 times 5. Okay? In order to decide and figure out what they can all grow to, I'm going to go through these factors and we'll pick off the ones that are ultimately what I call new. Okay? So this one here, because I haven't started, the first one always gets included. So 2 gets included. Now I'm going to go through the rest of the factors and choose the new ones. If I see 2 again, I'm not going to choose 2 again. Does that make sense? So I go through here and I get the 1. Now multiplying by 1 really it's trivial, so I'm not going to take that. I'm not going to use that. But then I get to the 5. Is 5 different than 2? Yep, so 5 becomes part of it. Okay? I get to 3. Is 3 new? Is it different than the 2 or 5? Okay? And then I get to this 5. Is that new? It's not, right? I've already got a 5 in there. So I've run through all my prime factorization values, okay? And I take 2 times 5 times 3. What's 2 times 5 times 3? 30. And that identifies then the number that I'm going to get all of them to grow to. It's the fastest way to find the LCD, okay? So when I look at this, and that discussion is going to help us decide what we do here. What can you make? Now, when I say grow to, it means some of them can stay the same, okay? But what can I make all of those denominators grow to? So they all become the same number. I can make them all turn into 8 through easy multiplication, right? Okay? So 8 is my least common denominator. We're always looking for the smallest number that I can make them all grow to. Okay? And that's called the LCD. The reason I want to find that is because I want to multiply everything up there by 8. And the reason for doing that is to avoid really having to do a lot of work with fractions. If I can multiply these all by 8, so I write it this way, but then I'm going to write it a separate way as well. That's what I'm talking about. Multiply the left-hand side by 8, multiply the right-hand side by 8. And when I do that, doesn't that require me to do that. Does that make sense? I'm going to distribute now. So 8 times n over 4. Well, that's going to give me 8n over 4. I'm just multiplying fraction times a fraction. Minus then, when I multiply here, 56n over 8. And that's going to give me 8 over 4. Now, most people are not going to write it that way because of what happens next. What's 8 divided by 4? 2. So, when I multiplied by 8, it turned all these fractions into things that will reduce to whole numbers. 8 divided by 4 gives me 2n. 56 divided by 8 gives me 7. 8 divided by 4 gives me 2. Do you see how multiplying everything by 8 got all the fractions to disappear, and now you've got an equation that is easy to solve? What's 2n minus 7n? Negative 5n. So I get negative 5n is equal to 2. And now I'm going to divide both sides by negative 5, right? So I get n to be negative 2/5. All right? So we chose the LCD, the least common denominator. Now, can everybody see up there that we could actually make everything grow to 16? Yeah. Okay. So I could have multiplied everything by 16. I could have taken n over 4 minus 7n over 8 equals 1/4. Multiply everything by 16. So I get 16n over 4 minus, now 16 times 7 is going to be 112 over 8. Okay, and then this is going to be 16 over 4. Okay, well, when I solve this, 16 divided by 4 is 4n. Okay, that's going to go to 14. And this is going to go to 4, right? Does that make sense to everybody? This give me negative 10n is equal to 4. Divide both sides by negative 10. I get n to be 4 over negative 10. Does that reduce to negative 2/5 again? So I could have multiplied by 16. You could multiply by 32. You could multiply by 64, 128, okay? Those would be common denominators, okay, but they're not the least common denominator. Does that make sense? 8 is the one that's least, because look at this. Would you rather deal, and I got the same answers, but would you guys rather deal with coefficients like 2 and negative 7, or would you rather deal with 4 and negative 14? Aren't 2 and 7 smaller? So in regards to being able to do like quick mental math, we'd like to use smaller values. So that's why we choose the LCD. Okay? But if you ever forget how to figure out an LCD, if you're to multiply all your denominators together, so take 4 times 8 times 4. Okay, so that's what? 4 times 8 is 32. Times 4 again, what's that? 128. If you multiplied everything out there by 128, you would be able to get rid of fractions. Does that make sense? Okay. There will be more discussion on that type of problem later on, but I think that's probably the best way for us to work through and solve that. Okay. What I would think that maybe you guys see this. Maybe, oh, that was terrible. What if I take, would it be fair to rewrite this as 2n over 8 minus 7n over 8? Does that make sense? Is that still 1/4 n? I'll say equals 1/4. The idea then is, well, if I got 1/8, let's use the factoring, the distributive property backwards, which is factoring. Can I do something like that? Do you think that would work? If I multiply 1/8 by 2n, does that give me 2n over 8? Take 1/8 minus 7n, or times 7n, does it give me negative 7/9, or negative 7n over 8? Does that make sense? So these two things are the same. That's the same. If I multiply this side by 8, I can group those two together, multiply this side by 8, I get 2n minus 7 equals 2, and I can do it that way. Still get negative 2/5 as n, okay? But I think that right now is maybe not the best approach for us to use for this type of problem. I think trying to use the LCD and get rid of the fractions is the best thing. Okay. I like this question here, and I think a lot of us might have missed this question or struggled with this question. What Math Excel is doing right now, they updated it, so it's giving me, it's spitting back the questions that we had multiple attempts on. Okay, so maybe we got it all right. Maybe everybody got full credit on this one, but it took like 3 attempts per person to do it. Okay, so it spits back this one as being one of those questions that's flagged. It says you have $55 in your bank account. $55 in your bank account. You are then every week going to take $25 from your paycheck and $9 from your allowance, and you're going to add that to that 55. But you're going to add that weekly. Okay? So we look at our equation here. Okay? Your bank account's amount is or will be your original $55. Okay? But you're going to add to that 25 plus 9. So 25 plus 9 comes from 25 from your check, 9 from your allowance, but you're going to do that every week. So in the first week, W would be 1, and you'd be adding 34 bucks. Okay? The second week, okay, you would have had 25 plus 9 for week 1, but then you also have another 25 plus 9 for week 2. Does that make sense? So that's why that W is getting multiplied there. Okay? So they ask you, how many weeks will it be before you have $255 in your account? Well, if this is the structure that's going to allow me to figure out how much money, remember this is my bank account, how much money I'm going to have in my bank account per week, okay, I should be able to say, well, if that needs to be $255, and I'm trying to solve for W. How many weeks does it take me to get $255 in there? So I'll subtract 55 from both sides. That's going to be 200 is equal to, now this just turns into what, 34 W's? Does that make sense to everybody? Okay, divide both sides by 34. And now tell me that it's going to take, when you divide that out, it's about 5.88 weeks. Okay? And those are types of things, guys, that people say, I'm not going to ever use algebra again. That's where you're going to use algebra. You're going to, at some point, want to think, okay, I've got this much money in my bank account. I get paid this amount every 2 weeks. How much do I need to save so that I can purchase something later on, maybe in 3-4 weeks from now? Does that make sense? You can set up equations like that to give you an idea of how many weeks you need to save for maybe a big purchase down the road. Okay? Now, I think some of us are missing these because I give you and this is just the way that the questions are designed with this author. You get 12 questions and they're all whole number answers, right? They're all 5 and then 7 and then -8 and then 12 and then 13. And then you get one at 5.88 and it's different than the others, right? And you think you've done something wrong. If you rely on your math and rely on your procedures, don't worry about what way the answer looks at the end. Okay? We're worried about steps 1, 2, 3, 4 through here. And if I know that I did that step right, I did that step right, I did that step right, that has to be right. Does that make sense? Okay? So don't worry that number looks different than anything else. And this last one here, it's another one where the answer looks a little bit different than previous questions. What's -3 and this parenthesis r plus 9 tell me to do? Okay, -3r. Good, so you got to multiply that by that 9 too, so it's going to give me -27, right? Okay, so now what I'm going to do? Add 27 both sides, good. So now I get -3r on the left. This is going to give me negative 29. Divide both sides by negative 3 then. So what's a negative divided by a negative? Positive. So negative 29 divided by negative 3 will be 29 over 3. Now, 29 is a prime number, meaning the only things that divide it are 1 and 29. 3 is a prime number, meaning the only things that divide it are 1 and 3. Because the 1 and 29 and the 1 and 3 aren't sharing any factors, there aren't, the 29 is not shared by the 1 and the 3, and the 3 is not shared by the 1 and 29. That's simplified, right? Okay? And I think that's what's throwing some of us off, is that, again, we get 15 questions where the answer is a whole number, and we get to the 16th one, and 29/3 is the answer. Okay? Those are fine answers. Okay? You can have fractions. You can have just nasty-looking values. We just got to realize, did I do all the steps correct? Does that kind of make sense?